the pulse audio server in the VM on the server part and have it do all the mixing and just send one stream data out. But I actually like it that if that you can connect your local pulse audio daemon directly to the client side, to the server side, so that programs on the server side uh, also can see every um, sound card you've got in your client system and stuff like that.
Mm-hmm.
But
Okay, and we're back with the live streaming, so feel free to continue whenever you want.
Okay, shall we repeat what was been lost, or?
That would totally be a good idea, yes.
Yes, so we had first a question about submitting it to the mailing list. So yeah, there's been some doubts about whether this is appropriate in Pulse Audio, but we're going to give it a try anyway. And there was another question about that this hides the
client
devices.
side
Yeah,
sound cards,
yeah,
the information of pulse audio itself. Yeah.
Yeah. So yeah, well, this is a bit of a matter of preference of taste, really. In our particular usage, this is kind of more convenient for us because we don't want the remote machine interfering in any way with the client's audio system. Like, for instance, we want to be able to deploy highly locked down environments in which the user can't change anything and can't screw anything up. So in that sense, this is a very highly preferable solution. But of course, I mean, it's open source. You can disable it if you want and to go back to the old system. That's also a possibility.
Yeah, but that's not helping if you want to have compressed data. So,
well,
well, basically, I mean, I cannot compress the data if I just connect to my local client-side Pulse Audio server directly, and that's my problem with that approach because it's not transparently in the transport path, but it's on one side only, or you compress the data after it comes out of Pulse Audio. You basically compress everything that is being sent over the TCP stream, right?
mm-hmm.
Right.
Nito would like to say something.
Okay.
Nito, unmute yourself and.
Yeah, sorry, I was muted. One of the ways you could actually implement it would be if there would be compression on the channel side.
Yeah.
On the next channel. So you would be, the difference is that Opus is really optimized for sound. So it's a compression protocol specific for sound, but nothing stops you to have compressed channels. So you would be able to use compressed channels either on SSH or an X, depending what you use.
Mm-hmm.
Yeah, sure, but I still don't get the benefit. I mean, I'd like Pulse Audio to automatically compress and decompress the audio stream as it's being sent over the network transparently.
But that's difficult because
yeah,
it would be a change on the client library. It's a Pulse server socket.
Yeah. Okay. So by the way, if possible, we should kind of leave this for a bit later because I'm going to cover a couple things that might kind of illustrate how we're doing this, and perhaps that will kind of inform a bit of the discussion for a later time.
Martin, before you go on, Uli had a question as well.
Okay.
No more.
Okay. So we slightly refactored this patch. We've upgraded to the latest version of Pulse Audio. We've made all the Opus parameters configurable that could be made configurable that wasn't in the original. And we've also managed to make them possible to change at runtime, which opens some interesting possibilities, like, for instance, just having the user just open settings dialog, for instance, and change their audio quality, or even fancier things than that, or have automatic adjustment. Okay. Now, so a simple illustration of how this works in Pulse Audio. This probably doesn't mean very much to people who never got deep into it, but it's actually pretty simple. Pulse Audio has a control system with the PA-CMD command, or you can just put this into the default .pa config file. So what we're doing here is on the server sender, we're loading a module. That's module channel sync new. Sync in Pulse Audio terminology is anything that receives audio and outputs it somewhere, like speakers or a network socket. We just give it a name. We tell it where the server is, where to send it. And the compression equals opus. That's the only addition we need in additional that's not in the Pulse Audio documentation without the patch. So this is pretty much the standard setup that you'd see in the Pulse Audio documentation. And on the receiving side, you need to load the native protocol module, and it's preferable that you set up a limit IP-based limit, or there are different authentication options in there, just for security, so that if you don't want anybody connecting to that. Okay. And here's an example of how one would modify parameters. There's a update sync prop list command, which we've used to, for instance, change the active bandwidth for the encoder, and this takes effect immediately, so that you can just do this in the middle of a connection. Right. So now there's the interesting bit. How do we implement this in QED in the client? Well, we support multiple operating systems, and on Windows, we just build and package our own Pulse Audio. So this is pretty straightforward. We've already been doing that. And there's that bit of configuration above, but there's nothing complicated about it. Same on OS X, of course. And on Linux, there's a difference. We now must build and package our own Pulse Audio, but this gets a little bit more complicated. So we have three possibilities on Linux. First is that the system supports Opus natively. That's in the case if our patch has been accepted upstream, already merged, and the user has already it installed, which currently is not the case, unfortunately. The second possibility is that the user has our own Pulse Audio package, which is what we provide. And the third possibility is that the user doesn't have our package, nor do they have Opus compression. Well, this is not a configuration we intend to use, but it's supported by the client anyway. Like, it's going to figure out you don't have compression, and it's going to give you a warning that, well, compression is not going to work, but you're going to have audio anyway. Right, so here comes the tricky bit. Running a custom Pulse Audio on Linux. First of all, it's probably people have realized that replacing the system Pulse Audio is a bit of a dangerous idea. For quite a few reasons, actually. First, it needs to be done for every distribution, and of course every version of each distribution. It would be easy to get something wrong and break the user system. And the custom Pulse Audio will be there even if our client is not running. And while we do have setups that are just very specifically for custom made for custom deployments, we certainly do intend to be used by normal people who just download the client from our website. And of course, this makes upgrades quite complicated because we have to keep track with every update of every distribution that we support. So we don't actually do that because, well, that wouldn't work all that great and will be kind of a pain to maintain. So what do we do? Well, first of all, we do have one instance in the virtual machine, as we already mentioned. And we do have two instances on the client side. So this is the funny bit. One is our patched version, and one is the system's own version. And the way it works is that we actually have a tunnel that first goes from the virtual machine to the patched version to the system version. And our own version just adds as the compressor for the audio. So this is a bit of extra complexity in the system, but not too bad actually. And the client actually checks if you have Opus compression in your system pulse audio, and if you do, you can skip the entire part about running two instances on your system. So here's a little diagram for what this looks like, just for clarity. We have VM server, which runs multiple desktops. There's a pulse audio with our patches running in there. The connection goes through the NX media channel. That's already the compressed audio, and it reaches the QED client on the Linux client's user's machine. From there, the compressed audio is forwarded to, again, a patched version of our pulse audio. And it decompresses it and sends it to the system one. And there are control channels established with both of them for establishing all those connections and authentication. So the difference here is that since we have our own pulse audio, we don't really care about any kind of distribution-specific functionality, and it only runs so long our client runs. So it's just very tuned for our particular application and really nothing else besides that. So how this works, the Linux client talks to the pulse audio using the Unix socket. In the same way the PACMD command does, if anybody has used that. It tests if the system pulse audio supports compression. It will launch our patched version if it's needed. And it sets up the network connections between them. Right, on the Windows and OS X sides, it's quite a lot simpler. The client launches our custom pulse audio build because, well, it's not there's no pulse audio on those systems. They have a custom-made configuration file that gets rewritten to load the right modules and absolutely nothing else. And there's no system pulse audio, so there's the entire forwarding setup just isn't there. Okay, so there are some challenges with this setup we've encountered. First of all, pulse audio doesn't actually provide a very good way of checking if the compression is supported. Like it would be nice to have some way of checking which version of a module is there, for instance, but unfortunately that's not there. So what we actually do is just to attempt to set up a connection and see if it worked. It works fine, but there are a couple of things there that I don't quite like. But we haven't had any actual trouble. And the second issue is that we actually need a quite custom build without dbus support on impulse audio and a custom home location to avoid them interfering with each other. So yeah, it works, but it took a little bit of work to convince two pulse audio instances on the same system to cooperate with each other. With the hope to make some future improvements, possibly improving the detection of what the system pulse audio supports. This is kind of a little thing, but well, it's in there anyway. And the more important one is the take advantage of the possibilities of runtime control. So we could be doing a better job doing things like, for instance, detecting congestion and automatically dropping bandwidth, or offering the user the ability to tune the parameters more deeply. Currently, this is still in the works. Right, and I guess that will be it. Questions?
Nito would like to speak.
Yes, of course.
I actually have a question for Uli. Uli, is there a way for to know which bandwidth or which bit rate is actually being used inside of NX? Are you aware of anything like that?
There is code for congestion control, but that is incomplete as far as I know.
Okay.
So I think you could get some numbers from that system, but neither in a convenient way, nor do I know if that's in any way correct or usable.
Okay. Thank you.
I'm wondering if you can also support systems that do not have pulse audio at all, just older systems that only have, let's say, some kind of ELSA or so.
Not really kind of the standard setup that we target. I mean, we are a consulting company. If you have a particular situation that needs it, we certainly could discuss it. But I mean, as a kind of consulting kind of work, I mean. But yeah, I mean, these days everyone runs pulse audio, so that's the setup we made the client for. But yeah, the source is out there. Certainly, it could be modified to work with something else, should there be a need for that.
Oh, just curious.
Mm-hmm.
I mean, if you compress everything down to, well, not really compress, but if you push down everything to one stream, to one audio stream, well, I don't see why you wouldn't be able to give that directly to author or something like that and play it back. But you'd have to forego pulse audio directly, maybe. After you did, but I mean, you probably still need a custom pulse audio build to receive the data. But you don't need to hook into the system pulse audio device or server, which also means that this will make building your special pulse audio server more complicated because you need to include support for ALSA and UDEF and other stuff.
Yeah, certainly.
Sure.
Yeah.
Wouldn't it be sufficient if you took out the decompression, the ALSA protocol and the decompression, and implement that in a small library, and then simply use the system audio? Instead of going through all the pulse audio stuff again?
If you took what? Sorry.
You get a signal. You get a pulse audio protocol with the compressed audio on the client side. And then you route that to the pulse audio, and the pulse audio finally routes it to another pulse audio, and that one routes it to the sound device. I think it should be possible to drop your own pulse audio if you only take out the decompression and the pulse audio protocol into a small piece of code and pass the result of that decompression to the local sound system, whatever it might be.
Well, so of course, but you'd be pretty much writing your own audio server. So this is the native Pulse Audio protocol. It actually does things like controlling latency, and there's a possibility of sending commands over it. So it's not really straightforward, and really you'd have to interpret this protocol and deal with audio devices. So yeah, of course it can be done, but it's not really trivial.
So there's no chance to build a Pulse Audio module for your client side that you just hook into the existing Pulse Audio?
You could do that. I mean, it's the Pulse Audio is on our GitHub. You can build anything you want on it, and of course mess around with the client if you want to. But the intended setup is that since it just forwards everything to the system one, well, you just can just load any modules you want in the system one, which is already fully featured and can be is the normal way the system is kind of supposed to be used.
I think Alex has some similar setup in mind. He mentioned that some years ago at some gathering. Does anyone know if he has implemented anything?
I'm not sure if it was Alex or if it was even Mike, but one of those two, Mike one actually, but one of those two mentioned an audio driver or some virtual sound card device or something that he came up with. So that was one
Probably
part.
Alex, yeah.
I don't remember, but I think it was Alex.
Mhm.
Well, I think we should have something similar in X2Go.
Mm.
So the question is, how modular and how portable is the code that Kindle wrote? How easy is that to port over to X2Go?
Well, the code is on our GitHub. Feel free to take a look. And the kind of the command that we use is right there in the presentation. I can actually, I'll just upload that somewhere later. So, and I'll be around. So feel free to talk to me, and we'll see where we go with this. So yeah, just give me a second. Yeah, here's my email address if you need it. And yeah, my name is complicated, so I should have an alias that's just my first name at kindle.com as well. So yeah, so if you want to discuss this, you can mail me or the team.
Okay.
Maybe you would like to contribute that.
Unfortunately, I'm pretty busy already, but definitely I'll consider it.
Okay.
So, any further questions for Vadim?
Yeah, just to be sure, the Pulse Audio on the server and the Pulse Audio on the client is the same binary?
So yeah, let me just scroll down to this.
No, I can say that in another way. You only distribute one open Pulse Audio package. You don't distinguish between server and client.
Yeah, it's the same package on both sides, right? So here I indicated with the little icons, like you see. Here's depending on which logo is next to the Pulse Audio one. That's the one in use. So yeah. So yeah, the same package can be used on both sides. At least if you have the same distribution, like it's Ubuntu on both sides. So yeah, the same package works.
Okay, thank you.
Okay.
I may have missed it.
Yeah, go ahead.
I may have missed it, but how do you interconnect two Pulse Audio well, devices.
Oh yeah.
By using virtual things, right? And
Yeah, this is just exactly the same that. Wait. What? Wait, it doesn't want to. For some reason, it doesn't want to go backwards. Okay. So yeah, pretty much this. So the only difference, and this is just the same between the two pulse audios, the only difference is that you skip the compression bit, and because well the system one doesn't support it.
okay, so a virtual thing that connects to a different server. Okay.
Yeah, this is in the pulse audio documentation. You just search about the tunnel sync and native protocol TCP, and you'll find all the information about how to set it up and how it works.
Now you have a controlled environment on your server side. You have you set up the VMs yourself.
Yes.
When we consider transferring your work to an X2Go server, this might run on any machine set up by anyone. So chances are that there is already a pulse audio running.
Yeah, that's quite possible.
Is that a problem?
Well, you'd have to replace it for it to support compression, of course.
Yeah, I'm not talking about compression. I'm talking about configuration-wise. I'm not sure how pulse audio is working.
It's not really a problem because you can just start it in a different home directory, have its Unix socket lie not in the default location, or spawn a TCP connection on a different port, and it will be basically separate from your system pulse audio server.
So
that's really not a problem. That's what we essentially do on OS 10 and Windows already.
Right. So here's the thing. The good part of this is implemented in our own client and our own management agent that runs in the virtual machine. Right. So to implement this in X2Go, well, you can certainly take the pulse audio patch, but then you'd have to write the functionality to actually deal with all the stuff in X2Go. So there is just up to the developer to choose how to deal with this.
No, I think you got me wrong. What I mean is, for example, I set up a workstation. I want to work locally, and when I'm not there, I want to work remote on that machine. So I start an X2Go session to the machine, and there is an X2 and Pulse Audio server already running. How can I prevent that the sound is going to the local Pulse Audio within my X2Go session? I'm not sure how the applications contact Pulse Audio. How do they find the right Pulse Audio server?
Is there a system variable for that?
Yep.
Yep.
I
But
mean, there's pulse server, pulse_server environment variable for exactly that case, but it won't help you, of course, if for already started programs, they will always reference the same pulse audio server. So you'd either have to restart your program, or you're out of luck, unless you try to.
With current X2Go.
Yeah. Well,
and with current or with pre-patched or with the QVD client before this patch was applied.
There's one. Sorry for interrupting,
Nico,
but this.
You raised your hand. Sorry. Go ahead.
One of the things that you could actually do is you can change the configuration of your local pulse audio to do a virtual sync or not. That is, and when you log in, you would need to do some kind of commands, obviously either manually with PA CMD, or you could actually script it whenever you do remote connection, saying, okay, now I'm remotely, reroute my pulse audio instead to the sound speakers to my virtual pulse audio. That could
Okay.
actually work for you.
Okay.
But you know that this is the control signaling that Vadim was talking about. You could actually signal your local and do fancy stuff.
Okay. If that pulse audio supports the fancy stuff I need.
No, because it's the virtual syncs is something that's pulse audio supported by default.
Forever. So from beginning of time, I think.
Well, not sure from when, but it's pretty old. It's pretty
Okay,
old.
so you can assume it's there. Okay, thank you.
Yeah.
Okay, if there aren't any further questions, then I would like to thank you all for coming. Thank you all for doing your presentations here. Have a good evening, have a good night, and to Uli and Ionic, see you tomorrow.
Okay.
Yep.
Okay.
See you tomorrow.
Yeah.